Yo, 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 Mr. Myers outra vez. Congratulations getting to the final video for the first lesson. We've been focusing on how to compare and order numbers, and the last learning goal means that we can convert a set of real numbers to decimals, then order them from least to greatest or greatest to least. So we're almost done with the first chunk of 8th grade math, so congratulations on getting this far. And we're going to continue to be successful throughout the year. Let's get started with our essential vocabulary. We have ascending and descending. You can probably tell that they are related. They are considered opposites. To ascend or ascending means getting bigger. It's a pretty ugly N. Getting bigger. Increasing. Or what we would say least to greatest. We're going to start with the smallest number and then just get bigger and bigger and bigger. So the numbers 0, 5, 10, they're getting bigger, starting with the least to greatest, 10. Or if we wanted a word example, it would be like climbing a mountain. As you're climbing, you're getting higher and higher. Your elevation is increasing. So a non-example, numbers 0, -1, -2, or biking down a hill. So this time you're not going up, you're going down. You're not getting bigger or increasing, you're decreasing. Technically this would be considered descending, the next vocabulary word. So to descend or descending is just the opposite. So if we're talking about numbers, we're getting smaller. Another word for getting smaller would be decreasing, descending, decreasing. Or in this case, we're going to start with our biggest number, greatest, to least. Decreasing from the biggest number to the smallest number, that's decreasing. So numbers 9, 8, 7, that would be decreasing, that would be descending. You could be, let's say we got the Olympics going on this summer, so jumping off a diving board. You'd be descending as you hit the water. And the numbers -5, 0, then +5, you're actually increasing. This would be ascending, so this is your non-example. Or we said we're climbing a mountain, that would be ascending. Well, what about if we are in a plane and we're going up in a plane? So taking off. In an airplane. You go up, 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 you keep increasing your height. That would be an example of ascending, okay, not descending. So this is a non-example. So I'm going to have to erase this, so pause it if you have to, so I can move on. Next thing, let's just review our golden rules real quick before we do a couple examples of today's learning goal. Number 1, positive numbers are always greater than negative numbers. So if I had $5 compared to -$10, I'd rather have the $5 in my pocket than owe someone $10. So +5 is always going to be bigger than -10 because it's positive. So I mean, we could look at something as extreme as this. Sure, 1,000 positive would be a big number, but -1,000 is actually a very small number. So again, I'd rather have this $1 to my name than have to owe Joe $1,000. So again, the positive number is bigger than the negative number all day long. Golden rule number 1. Golden rule number 2, we're going to convert all numbers to a decimal, then fill in the empty spaces with zeros until all numbers have the same amount of digits after the decimal point. I know that sounds wordy, but all that means is if I convert some numbers like this, that's 1 5/10. And then if I had this, that would be 1 and 125 thousandths. What I'm really wanting to do, all this says is after I convert to decimals, I want to just make sure I fill in spots with zeros so that they have the same number of digits. So I'm comparing the 1s, the 5 and the 1, the 0 and the 2, the 0 and the 5. And it's a lot easier to tell that this number is the bigger number. That's all I'm saying in golden rule number 2. Golden rule number 3, this is probably the hardest one for students. This is the one that's the most important. So learning how to think about these problems is going to be really beneficial for you. We know that positive $5 would be bigger than $4. But if we're talking about negatives, now all of a sudden we're talking about the opposite of that. So all I have to do is ask myself, if they were both positive, like 5 and 4, which one's bigger? Well, $5 is more than $4. So now that they're negative, it's the opposite. The negative 4 is actually bigger. You can see that on a number line too. So if I have another example like negative 100 and negative 5, I'm going to ask myself which one would be bigger if they were positive. A positive $100 is bigger than a positive $5. But since they're negative, now it's the opposite. I'd rather owe someone $5 than owe someone $100. That just makes common sense, right? So hopefully you're learning to ask yourself the right questions. Which one would be bigger when they're positive? Okay, now it's the opposite. So pause that if you need to get that down real quick, but I gotta move on to the examples. So I went ahead and got a little bit of a head start on this. You can pause and catch up if you need to. So the only difference between today's now is we've got these kind of uglier numbers. We got to do a lot more converting, and then we're going to put them in order. But we're going to still use our place value chart to help us out. We can use a number line also to help us out. First thing we got to do is figure out what does the question want. This one wants us to order a set of real numbers in ascending order. Ascending means I'm getting bigger, so I'm going to start with least until I get to my greatest. I'm going up, getting bigger. So I need to first put everything into decimal. This one's already a decimal, so I can go ahead and put that into my place value chart, 27 and 5/10. I posted a video on how to put these in your calculator. Hopefully you've watched it. If not, then maybe you can learn it while I just do it here on the quick. First one's 9 pi, side by side means multiply. I don't need to put the multiplication in here because the calculator is going to do it for me. Pi is a blue number, so I gotta hit the blue button. Hit my little arrow. 9 pi. Check to make sure I had it in my calculator right. And it's 28 point a bunch of other stuff. My place value chart only has 3 decimal numbers, so I'm just going to put the first 3. 28 and 274 thousandths. That's just an estimate, right? Next, the other one's a little funky looking, but I'm just going to put it in the way of my calculator. 10, I have a square root. That's also in blue, so I'm going to get to my blue button. Boom, get my little house. Put the 30 inside the house. I need my parentheses because I only have the 30 inside my square root. And I know that fractions are dividing, so that last thing I got to do is get my fraction bar, which is the divide symbol. Divide by 2. Check to make sure I put it in right. Looks good. Hit enter. I can see all these numbers are pretty close, so I'm going to really need to pay attention to golden rule number 2. 27.386. 27.386. So I mentioned golden rule number 2 because that's the next thing I need to do. I've got these 2 blank spots right here. I'm going to fill them in with zeros. And now I'm going to look for the smallest number. I'm doing least to greatest. So my 2's are the same, so I got to go to the next one. Then my 7's are the same, so I got to go to the next one. And then I see that the 3 is less than the 5. So this is going to be my smallest number because 3 is less than 5. I start here, the 2's are all the same, I have to go to the next one. Now I've got just these 2 that are at 7, and finally I can tell that this one's smaller because 3 is less than 5. So my first one Which one was that? 27.386. That was this. 10 times the square root of 30 over 2. That's my smallest number. Where does that fit onto my number line that I already wrote? Okay, well, 27's here, 28's here. That means that this must be right smack in the middle, would be 27.5. This is a little bit less than that, so about here would be the 10 square root of 30 over 2. So this is 27.5. So I can see that this is smaller than this. And then 28.274 would be somewhere in between 28 and 28.5. So somewhere about here would be 9 pi. So then this is number 2, my 27 and 5/10. And then finally 9 pi. 28 is bigger than 27, so I can tell that that's my biggest number. $28 is bigger than $27. So if you look at your number line, I'm just going in order. Smallest, next smallest, bigger. It's in order on the number line. It can be a very, very useful tool. My fiance is always like, why don't they just use a number line? Well, sometimes it's easier to use a number line. Sometimes we can just use our common sense and our golden rules. Sometimes we can just use the place value chart. There's all kinds of ways of doing this. You pick what's best for you. Alright, so if you need to write that down, pause it. If you want to try the next one on your own, you can pause and give it a shot, but I'm going to move on anyway, just for the sake of time. Second example, last example of this video. This time we're ordering the set of real numbers in descending order. Descending order. So descending means decreasing, so I'm starting big and getting small. So this time it's greatest to least. So I've gone ahead and worked ahead and kind of set some of my numbers up so I can get a head start. This first one, -6 1/2, that's going to be the same thing as -6 and 1 divided by 2. I have to do it old school in my calculator. I'm not entirely sure why I can't do what that video said to do in this calculator, but it's just an online thing. So there's always a shortcut for these things. So -6 and 1 divided by 2. So I'm going to do the 1 divided by 2 part. That is 5/10. So then I can just put it all together. And -6 1/2 would be -6, and as the decimal, 0.5. -6.5. So I'm going to put my first one in here, -6 5/10. The next one, to do percents, remember that we need to divide by 100 to get rid of that percent sign, per 100. So 72 5/10 divided by 100 tells me that 72.5% is actually a pretty small number. A lot of students get confused on this. They forget to divide by 100. Sure, it might look like a big number, but when you actually turn it into a decimal, you see it's actually a very small number. So that would be 0 and 725 thousandths. Next one, I've got -2 pi. Side by side means multiply. So I don't have to actually put the times pi. My calculator's smart enough, but the pi is blue, so I'm going to hit the blue button first, then hit it. -2 pi is this ugly number. -6.283 would be a good estimate for that. We don't need to keep going. 6.283. And lastly, all this is 46 over 7 is 46 divided by 7. Fractions are multiplying. So 46 divided by 7. There we go. So now I've converted everything to a decimal. That's always my first goal. 0.5 6.571. So positive 6.571. Now I'm going to think about golden rule number 2, which tells me to fill all my spots with zeros. You might not have actually automatically done 0.725 since my calculator said 0.725, but I know that there's always a decimal, always a zero in front of the decimal when it's written like this, and you can figure that out anyway by doing golden rule number 2. Alright, so we want greatest to least. We want our biggest number. Golden rule number 1 tells me that my positives are bigger than my negatives. So I'm going to start by looking at my positives to find the biggest number, and it turns out to be pretty easy. So I'm looking at this value and this value right here. Well, 6 is bigger than 0. So I already know that my biggest number is this 46/7. This is my biggest value. 6 is bigger than 0. Again, golden rule number 1 tells me positives are bigger than negatives. So then this has to be number 2 because it's still positive. So what was that? That was 72.5%. It's very helpful to stay organized so that your answer choices are going to use these numbers, not these numbers. So you need to make sure you're nice and organized so that you can figure out which number goes with what. 0.725 is the 72.5%, just to keep that nice and clear. Alright, well now I'm moving on to my last two values, trying to figure out which one's the next biggest. Well, if these were positive, well, the 6's are the same, and then I've got a 5 and a 2. So if these were positive, I know the 5 is bigger than the 2. So this value would be bigger. 6.5 would be bigger than 6.2. But they're negative. So then 6.2 is actually bigger. Negative 6.2 is bigger than negative 6.5. Again, I ask myself, which one is bigger if they are positive? 6.5 is bigger than 6.2. But since they're negative, it's the opposite. Now that means negative 6.2 is actually bigger than negative 6.5. So this would be number 3, and this is my smallest number. So 3 was 2 pi, or negative 2 pi. And lastly, my smallest number, my least number, was negative 6 1/2. That does it for our second example. There's another video I posted at the bottom of this page that gives you another explanation and some more practice. We're using the same games as last time, because if you can compare two numbers, then as long as you understand the vocabulary, like descending and ascending, greatest to least, least to greatest, comparing two numbers at a time should be enough to get you to put them in order. Just going two at a time. I should actually do the number line on the quick. Negative 6 1/2. Well, this is negative 8. So in the middle is going to be negative 7. So a little bit less than that would be negative 6 1/2, negative 6.5. We know that this is going to be a little bit closer to negative 6 than negative 2 pi. Right there. 0.725 is going to be a little bit more than 0. Not quite 1, which would be in the middle of here. So right here would be 72.5. And lastly, 46/7 would be between 6 and 7, so about here. 46/7. I think using a number line is crucial. There are going to be some questions like that, probably on the star, about trying to put some radicals in the right spot. But anyway, this is the most important thing, being able to put them in order. I hope you found this useful. Again, there's another video you can look at, get some help in class, try the practice. Unit test is going to be coming up next, so make sure we got this down. Thank you for your attention. I will see you guys in class.